Okay, so we're going to solve a triangle, and here is where it's important to always use original data if possible. And this is the law of sines. I'm going to derive it in class for you and talk about it, but basically it says the sine of angle A over the length of side A is equal to the sine of angle B over the length of side B equals the sine of angle C all over the length of side C. And that's basically the formula that we're going to use. So here's a problem, and it says sketch the triangle and solve, and then round your answers to 2 decimal places. So let me take a look at my notes here so I get the correct problem out. I always recommend that you sketch the triangle so you know what your triangle looks like and you know what type of a triangle it is. So I'm going to draw it over here. It's not a right triangle, and it doesn't actually matter now which is angle C or side C. Alright, so I'm just going to go in alphabetical order here, A, B, C, which means that this is side A, this is side B, and this is side C. And I am going to label my angles now. Okay, so I'm given that side B is equal to 7, and that angle A is 23 degrees, and angle B is 42 degrees. So this looks like I have a side angle, right? And so that's okay, and that means that we'll have one solution. We don't have to worry about the ambiguous case. So I'm going to make a little table over here like we did in the previous chapter, where you have angle A, angle B, angle C, side A, side B, and side C. Right, we're given that B is 7, put a box around that. So I know what is original. This is 23. Put a box around that. And then B is 42 degrees, right? So that's what I'm given. Okay, so what can I first find? Well, using the fact that the sum of the angles in a triangle is 180 degrees, I can first find that angle C is 115, right? If you add these up, 115, 42, and 23, you'll get 180. Okay, with that in mind, now what I can do is I can find some sides. I can find side A and side C, and I'm just going to go in order from top to bottom. Now, in order to use the law of sines, I need to know one of these ratios, and if you see here, I do have a ratio because I know what angle B is and I know what side B is. Okay, so that's what I'm going to use. So I'm going to start here. This is what I mean by using my original data. I'm going to use sine of 42 over 7, and that's equal to, well, I'm going to solve for little a first, sine of 23 degrees all over A. And now I just cross multiply to solve. So I have A sine 42 is equal to 7 sine 23. If I divide both sides by sine 42, I have A is 7 sine 23 all over sine of 42. And when I round that to 2 decimal places, I get 4.09. Right? Okay. Now, notice that this is not a right triangle, right? There's nothing in the instructions that say that this is right. This is not a right triangle, so that means do not use the Pythagorean theorem. The Pythagorean theorem only works for right triangles. So that means that we need to use the law of sines again to find side C. Okay, so again, we have to start with what we know, right? Our original data, and that is this relationship between angle B and side B, right? So we do again have sine of 42 over 7. Now this time it's equal to sine of C over little c, so we have sine of 115 all over little c. So cross multiplying, we have c sine 42 is equal to 7 sine 115. So c is equal to 7 sine 115 all over sine of 42, which means that c is 9.48. Okay, so that's what we mean to solve the triangle. I recommend that you draw it so that you can figure out what type it is, okay, and always use your original data. Now let's go back and check and make sure that our sides and our angles make sense, right? Your longest side, this is B, should be opposite your largest angle. Oops, so our largest side, sorry, is C, which is 9.48, right? That's bigger than 7. and that's opposite angle C, which is 115, so that makes sense. Our shortest side, side A, which is 4.09, that is opposite our smallest angle of 23 degrees. So without doing any major work, I can just check to make sure that my answer looks feasible. Okay, and so that's how you solve triangles using the law of sines. You need a ratio like this. You need to have a matching pair between the angle and its corresponding side. Okay, make sure that you use that original data and the law of sines to solve the rest of your triangle. Okay, you cannot use the Pythagorean theorem anymore. In my next video, I will solve a triangle that involves the ambiguous case.